Let's pick up our last two trig functions and talk about their graphs. So we're going to be sketching the graphs of the cosecant and the secant function. And let's start here with the cosecant function. And the cosecant is the reciprocal of the sine function. All right, so let's see. So it's actually 1 over the sine of x. That equals the cosecant. And if we go back to SOHCAHTOA, where the sine is the opposite over the hypotenuse, that means the cosecant is the hypotenuse over the opposite side. As we move into the coordinate plane, where the sine is y over x, well, this means what? That the cosecant is x over y. Now, where would we think we would see asymptotes? Let me back up. Let's talk about period first. Now, the period of the sine function we know is 2 pi. And in its parent form, this cosecant function would also be 2 pi, would be the period, but we see this 2 right here. And so that's going to affect the period of our cosecant function. And remember, the period in this would be 2 pi over the absolute value of b, and that makes 2 pi over 2, or just pi. So we're looking for a period of pi. And let's see, where would we have some undefined issues that would create asymptotes, infinite discontinuity? Well, let's see, we're opposite of the sine, so it's cosine over sine. When we get to pi over 2, yes, and 3 pi over 2, we should begin to see some discontinuity. All right, well, we're going to go graph that in just a moment. Before we do, we're going to take a look at the secant function. Now, the secant function is the reciprocal of the cosine. So it's 1 over the cosine of x. And again, period would be 2 pi. Of course, in this case, our period is going to remain 2 pi because we just got 1x, but we do see a translation, a horizontal translation. And that translation is going to be, let's see, we got c over the absolute value of b, so we ought to be, and that's 1. So we should see a phase shift of plus or minus pi, I believe. Should get us there. Horizontal or translation or phase shift. Well, let's move to the calculator and see what we got. And by the way, I like the way the cosecant and secant functions look on the graph. Well, let's see. First of all, I'm going to graph that cosecant function without any transformations. And so we'd have 1 over divided by the sine of x. Okay. Let's see. Let me think about my window settings. So we should see a 2. Let's change our window settings. Well, I've already got it. Looks like at negative 2 pi and pi. And a scale of pi over 2. Let's see what our graph looks like. See what I mean? I just love the way those things look. Now, let's look at our period. If I go here to the far upper left, right there, and remember I set a y minimum at negative 2 pi. And so it starts to head down there, and it goes back up at pi. So I see an asymptote coming right there at pi. I see another asymptote coming at 0. And just on the other side of the y-axis, on the positive side, I see we're starting to come down again. And so that marks our period, which is, in fact, 2 pi. Isn't that cool? I think that just looks so cool. All right, well, let's graph our transformation. And if you remember, this is the cosecant of 2x. So I'm going to graph that by 1 divided by, let's see, we're going to use the sine function. I'm trying to think about my parentheses, what I want to do with my parentheses. Should be all right. I'm going to go sine 2x, close my parentheses. Now, what should this do? This should adjust my period from 2 pi to pi. Let's see what happens here on the graph. Ah, yes. Okay, in the red, zooming in. And so again, I got a scale. I mean, my x minimum is, well, let's start over here at the y-axis. Shift it up a little bit. So we're starting to come down right here at the y-axis. X is equal to 0. And then we move over and we see it, but of course it drops down here into the 4th quadrant, and we see it go up and back down, and then, but right here we see just as that's pi over 2, that's pi. Yeah, sure enough, my period has adjusted from 2 pi to pi, the effect of that sine of 2x versus just the sine of x, 1 over the sine of 2x versus 1 over the sine of x. All right, well, that's pretty cool. Let's see, what else might we know? Sine function starts at 0. Okay, well, that might be why we see some horizontal asymptotes in here. All right, the next one was we're going to graph the secant of x plus pi. But first, I think we'll just graph the secant function without any transformation, without any phase shift. That x plus pi tells me we got a phase shift. We're going to go 1 divided by the cosine of x that will represent the secant function. Let's take a look at our graph. Okay, well, if I look down here in this 3rd quadrant, let's see, there's negative pi over 2, there's negative pi, there's negative 3 pi over 2, where we start our upward trend, flipping back down, and 1, 2, 3, 4, and I get to positive pi over 2, negative 3 pi over 2, period again starts at pi over 2. Yeah, that sounds good. That's a period of 2 pi. All right, let's graph our transformation, which was 1 over, and here I think I do need another parentheses. Yeah, I think I will. We'll put parentheses, the cosine of x plus pi. Now, our period shouldn't be affected, but we should see a phase shift. Let me get the pi in here and double close these parentheses. And let's take a peek at the graph. Ah, yes, see? Period's the same, but we have shifted over. If I look right here at the y-axis, I can see, let's say I shifted as plus pi, it shifted it to the right by pi, and period still 2 pi. Almost looks like some weird dental scam, doesn't it? A lot of teeth right here. Anyway, those are kind of fun to graph, and I always have liked the way they looked.